At Cape Canaveral, the countdown is in progress for the attempt to send astronaut John Glenn around the world. Weather conditions are good. The only element of doubt is a heavy cloud cover reported by observers at Cape Canaveral itself. But officials of the National Space Agency are hoping for a break in the clouds that will permit the launch. Here's how Glenn feels about it all in a recent interview with NBC correspondent Frank McGee.
Do you ever find yourself having some difficulty convincing yourself that it's really going to happen?
Well, no, I don't. We have been able through the period of time we've spent on the project to get quite a lot of confidence in the whole program. It's been a constant confidence-building program, really, in the equipment, in the people we work with, in our own abilities to conduct the mission. Fields really are important to each one of us that are involved in Mercury.
Of course, you were excited about it when you first got in it. Are you still as excited about it as you were?
Even more so.
Really?
Right.
It doesn't lose its luster or lose its taste?
No, it's by far the most fascinating program I've ever taken part in.
When you think of it, what do you think is the major accomplishment that this might bring out?
Well, I look at it myself as the beginning, really, of an exploration. And we don't know. That's the reason we're exploring exploration. I think it's an exploration into what the human body will run into in space, as to what the extent we can travel in space. It's also an exploration in the straight geographical sense. Explorations are conducted really to see what you will run into. If we knew in advance, there wouldn't be any point in making the exploration.
You're going to be terribly busy on this flight. You're not going to have time for a lot of sightseeing, but are you holding on to some hope that you might have time to look about you up there?
Well, we will, and in fact, on the missions, we will plan periods when we will do nothing but observe outside to see what we can see, what the sky looks like, what the stars look like. Do they still twinkle, or are they a steady light when you get outside the atmosphere? There are quite a long list of things that we plan to observe outside the capsule as well as inside.
Right now, John Glenn is just about sealed into the capsule, so let's go over live to NBC's Herb Kaplow at pad 14.
Sitting in Friendship 7 capsule, some 65 feet atop the Atlas booster 109D. Still a question this morning as to whether the launch will be able to take place. Clouds are hovering over Cape Canaveral. Weather people in Mercury control watching carefully to see whether they will blow away at an appropriate time for a launch and an attempt for orbits.
Merrill, I just noticed here we're at 63 minutes and counting, but word has just come in. We expect to hold at T-minus 60 minutes due to a broken bolt in the hatch. The permacord and the installation around the hatch where it's being installed has now been removed from the spacecraft Friendship 7, and technicians will have to hold at T-minus 60 minutes here in order to repair this bolt.
Colonel Powers at spacecraft control.
Holding. We have encountered difficulty with the liquid oxygen loading valve out in the launch pad area. We're at T-minus 22 minutes and holding. We estimate at this time an additional 10 to 15 minutes in the hold. This is Mercury Control.
Now here's Colonel Powers at spacecraft control.
Has just resumed. We are at T-minus 22 minutes and counting. The MA6 launch countdown is proceeding. We are at T-minus 22 minutes and counting. This is Mercury Control.
At minus 6:30, someone tells me that the count was stopped. Was it stopped? Was this count holding or counting? Holding. At minus 6:30, at T-minus 6:30, the count was stopped. We go now to Colonel Powers at spacecraft control.
MA6 launch countdown is at T-minus 6 minutes and 30. T-minus 6 minutes and 30 seconds. We have encountered an electrical power failure in connection with our computers in Bermuda. The power has been restored. We estimate it will take us about 5 minutes to get the computer back into condition to support the mission. This is Mercury Control, the MA6 launch minutes and counting. T-minus 5 minutes and counting. Mercury Control.
That's the go decision. There's one more to come. T-minus 4 minutes. The Atlas and the spacecraft are now on internal power. The inverter switches are now operating the spacecraft. We are in the last stages of fueling. In a few moments, The vents on the top of the rocket will be closed, and the entire vehicle will be sealed at that point for its space flight. We're at T-minus 330. Last stages of the fueling now going aboard. In just about 10 or 15 seconds, 35,000 gallons per minute of water will start pouring across the flame bucket below the rocket. Jay, will you watch for that and call it off when you see it?
I will, Merrill. And we might point out at T-minus 19 seconds, there will be a momentarily hold. This is built into the countdown. This is where the test conductor, Tom O'Malley, will take his last look.
T-minus 30, that water should start pouring. Can you see it, Jay?
Not yet.
It's got to keep that concrete and that steel around it cool. Otherwise, this rocket would scorch it and melt it in takeoff.
I'm not too sure, Merrill, if I will be able to see the water flow from here. However, we might get some indication of it.
They have not sealed the vents on the top of the rocket yet, either.
No, they have not. We're still venting.
This is Mercury Control. The MA6 launch countdown is at 2 minutes and 30 seconds and counting. 2 minutes and 30 seconds and counting. This is Mercury Control.
All fuel tanks on the Atlas are now at full pressure. T-minus 30, all systems go. T-minus 2, all fueling has been secured. The vapor has disappeared from the top, Jay, has it not?
It has. The vapor, LOX vapor has disappeared. The top boil-off valves are closed.
The automatic command system in the rocket has taken control over the booster. We are approaching T-minus 1 minute and the second go or no-go decision, the final decision on the system's check. We should have some word from Colonel Powers.
This is Mercury Control. The MA6 launch countdown is T-minus 1 minute and counting. T-minus 1 minute and counting. All systems are reported in a go condition. John Glenn reports he is ready. This is Mercury Control.
T-minus 45 and counting. All systems go.
That's the word at this moment. All systems go. There will be a...
T-minus 35. The main umbilical cord should drop. T-minus 30
this is
seconds.
Mercury Control. The MA6 count. T-minus 30 and counting. T-minus 30 seconds and counting.
This is the last human control. At any moment, the verniers should light. General Dynamics' Tom O'Malley starts these damping motors.
The Mercury spacecraft umbilical is out. We're at T-minus 19 seconds.
$18 seconds. The firing button.
T-minus 10 seconds and counting. 8, 7, 6, 5, 4, 3, 2,
there
1,
is the ignition of the verniers.
0. Ignition. Liftoff.
Liftoff.
The MA6 vehicle has lifted off. The MA6 vehicle has lifted off. Trajectory looks good. The MA6 vehicle is off the launch pad.
That is how it began, one of the great adventures of our time. Before it was over, Colonel John Glenn had orbited the Earth 3 times. His total time in space from launch to splashdown in the Atlantic was 4 hours and 56 minutes. During this flight, astronaut Glenn took over partial manual control of his Friendship 7 spacecraft for more than 3 hours, when trouble developed in the automatic control system. Glenn's takeoff, the potential dangers of his long flight in space, the decisions made during the flight. All this was held under the massive spotlight of minute-by-minute live radio and television coverage. America had put one of her sons, with his skills and that of his many colleagues, on the line for all the world to see. It is the way of a free people to act in this fashion. Let's return now to those early minutes and seconds that led to Colonel John Glenn's historic flight in space.
Liftoff. Roger, the clock is operating. We're underway. Roger, reading you loud and clear. Roger, we're programming it roll okay.
Altitude, little better than 3,000 feet. Speed a little over 200 miles an hour.
A little bumpy along about here. Roger.
Altitude, about 25,000 feet. Speed better than 700. He's approaching the speed of sound and maximum Q, the greatest strain the rocket can endure.
1 minute.
Altitude, 40,000 feet. Speed over 1,200 miles an hour. Vibration here in the rocket is dampened out by those Vernier engines, the little side fellows that wiggle and waggle.
We're smoothing out some now, getting out of the vibration area.
Roger, you're through max Q. Flight path is very good. Pitch 4-3.
Getting out real fine. Cabin pressure coming down, 5-7. Okay, flight very smooth now.
Altitude now, 75,000 feet. Speed about 2,500. He's leaving the atmosphere and entering space. It looks clean. The
Amps 2-5. Cabin pressure holding at 5-8.
Oh, Roger, reading you loud and clear, 7. Cape is go. We're standing by for you.
Roger, Cape is go and I am go. Our capsule is in good shape.
altitude 40 miles. Speed 5,000 miles an hour. The two booster engines are due to cut at any moment.
Roger, 0G, and I feel fine. Capsule is turning around. Oh, that view is tremendous.
Roger, turnaround has started.
Capsule turning around, and I could see the booster during turnaround just a couple of hundred yards behind me. It was beautiful.
Roger, 7. You have a go. At least 7 orbits.
Roger, understand go for at least 7 orbits.
He's on his space path now, his launch path toward orbit. The pitch angle is being adjusted now for that keyhole in the sky for orbit.
This is Mercury Control. All indications here are that we will be able to confirm orbit within a matter of a couple of minutes.
Confirming orbit means confirming an exact orbit. John can't miss an orbit now where he is. The only thing that can stop it is that it is either perfect or they're going to fire the retros and bring him down. But it sounds like it's perfect. He's right where he should be, right on the clock.
This is Mercury Control. John Glenn in the Friendship 7 spacecraft is traveling at a velocity of 17,545 miles an hour and is in an orbit ranging from 100 miles at the perigee or low point to an altitude of 160 miles at its apogee or high point.
The world waited and watched and prayed while Glenn began his first true orbital flight. Each orbit would be considered as a separate segment, although space agency officials had made no secret of their hope that Glenn would be able to orbit the Earth the full 3 times. The first orbit would test Glenn's ability to function under the condition of weightlessness. It would also disclose any bugs in the operation of the spacecraft and test out the complex control system around the Earth. Here's how the actual first orbit went.
Everything is go. John Glenn is in orbit, about 100 to 110 miles in space. By now, he must be higher. He's over the western African coast. And gradually, of course, his space capsule rises as it goes down toward Australia and picks up speed, then begins to sink again and slow down. That also explains the expression between John Glenn and the ground control, you are go for 7 orbits. He's a little bit lower than program at the outset, and he'll be a little bit higher than program. Therefore, gravity is going to have a little greater grab on his space capsule. That will slow him down. To Colonel Powers at Spacecraft Control.
This is Mercury Control. While you were listening to the tape of John Glenn's communications with the Capcom, Alan Shepard here in the control center, the Friendship 7 spacecraft has passed on its orbital track, has now passed over the Canaries, and is about to establish contact with our tracking station at Kano in Africa. As it passed in the vicinity of the Canaries, John Glenn reported, I am very comfortable. All systems are okay. He reported that the horizon was a brilliant blue and that he had the Canaries in sight out through his window. He also said he had a beautiful view of the African coast and that part of the Canaries were obscured by clouds. The flight appears at this time to be proceeding as planned. The Friendship 7 is in orbit, passing in the vicinity of Kano, Africa at this time. This is Mercury Control.
Okay, do you have any other landmark observation to make, over? This is Friendship 7. I have a plan to use this light out here, very clear. Picking up some of these star patterns now, a little better than I was just off of Africa. I understand your Pleiades in September. You sighted Orion yet, over? Negative. Do not have Orion in sight yet. ahead. Roger, within a few seconds you should have Orion and Canopus and Sirius probably in sight very shortly thereafter, and the moon will be off to your right, over. Roger. You have time to send us a blood pressure reading, over. Roger. Stand by. Just to my right, I can see a big pattern of light, apparently right on the coast. I can see a outline of the town and a very bright light just to the south of it. Roger, that is Perth and Rockingham, you're saying there. Roger, the lights show up very well. Thank you, everybody, for turning them on, will you? Roger, sure will, John. Very fine. On down farther to the south and inland, I can see more lights. There are two, actually four patterns in that area. And also coming into sight in the window now is another one, almost down under me. The lights are very clear from up here. Roger, sounds good.
A number of interesting things out of that report, but I think the most interesting thing is that if anyone could be cooler than John Astronaut, I'd like to meet him. First thing he reported was a large city just under him to the right. That could have been Adelaide. He was by this time well east of Perth, and it might have been Adelaide that he saw, but then he reported almost a few minutes afterward that he'd suddenly started passing over a cloud bank. To pick this out in darkness is a fantastic bit of observation and navigation. You also heard him explain that he was seeing this to his...
This is Mercury Control. The tracking station, located at Guaymas, Mexico, reported initial telemetry contact with the Friendship 7 spacecraft at 09. That's 11:09 Eastern Standard Time. Voice contact has been established, however, we are not able to read it very clearly at this time. We do know that they are in voice contact, that is, John Glenn from the Friendship 7 spacecraft and our communicator at the Guaymas, Mexico tracking station. As of this time, all systems appear to be in a go condition. Our cabin temperature is a little bit higher than it was, up about 105 to 108 degrees, but we do not feel that this is any particular concern at this time. This is Mercury Control with the Friendship 7 spacecraft approaching the west coast of Mexico at this time. This is Mercury Control. This is Mercury Control. I have some new acquisition times. Our initial contact with the Friendship 7 spacecraft from here in the control center was established at 21 minutes after the hour. That is 11:21 a.m. Eastern Standard Time. We were able to hear the remote relay of the voice contact between John Glenn and our tracking station at Guaymas, Mexico. During that voice broadcast, Glenn reported that he had observed some small particles near the capsule moving at approximately the same speed as he came through the sunrise phenomena. These particles caused him no difficulty, but he did observe them during the flight. They appeared to glow in the sunrise. As he passed across the southern part of the United States, Glenn reported some minor difficulties with his attitude control system. As of this time, Glenn is manually flying the spacecraft on what we call fly-by-wire, a form of automatic pilot-type device. He made contact with the Bermuda tracking station at 26 minutes after the hour. That is 11:26 a.m. Eastern Standard Time. He is continuing to maintain attitude control with the fly-by-wire system. He reported that it was very smooth and was not having any trouble controlling the spacecraft. As he passed across the east coast of the United States, he reported he had a beautiful view of the coast. He, at that time, could not see the Cape, but expected to do so shortly. He has now passed east of Bermuda, going down the second leg of the second orbit in the Friendship 7 spacecraft. This is the Mercury Control Center.
Glenn will attempt an unusual test. This should be going on at this time. This is an ocular gyric test programmed by the flight surgeon. Basically, the test will be to see if the astronaut still has his normal sense of balance after staying in continuous state of weightlessness this long. They'll see if Glenn can tell the difference between up and down by flying the spacecraft in different positions. As we heard from Colonel Powers moments ago, he has command of the spacecraft on fly-by-wire. To his right-hand control system, he is using small electrical switches at this time to control the pitch and yaw of his spacecraft through the attitude control jets using hydrogen peroxide. He'll see if he can maintain this correct tilt at 34 degrees with the horizontal, and apparently he's doing so, and the weightless state has not affected him at all after being 1 hour and almost 1 hour and 40 minutes in the weightless state. He is set now to execute the biggest maneuver of the Friendship 7 while in orbit, and that is coming up in 5 seconds. Using the fly-by-wire system of control in which he is on, Glenn will free the gyros that hold the spacecraft in its automatic position, and then turn the Friendship 7 around to fly forward instead of backwards, as he has been doing since he was inserted into orbit about 1 hour and 50 minutes ago. After completing the 180-degree yaw maneuver, Glenn will hold the spacecraft in the forward position for 2 or 3 minutes and take a good look at where he's going before returning to his backward position on the correct angle with the Earth for immediate re-entry in case of trouble. The astronaut has about 6 minutes to make this maneuver, see what he can see and where he is going before returning for his fourth 30-minute report after 2 hours in space. The most important thing about this is that when he makes this turnaround and is flying forward, he is not in re-entry position. In case of any type of trouble whatsoever, he must maintain this re-entry position. And that's why he'll only stay there 2 or 3 minutes, and why the maneuver will be only executed if the flight appears to be moving along as programmed and in good condition.
Roger, this is Friendship 7 controlling manually on fly-by-wire. Having no trouble controlling, very smooth and easy, controls very nicely. Fuses are still the same on the left panel.
Roger.
I have beautiful view out the window of the coast at present time, just departing. Can see the way down across Florida. Cannot quite see the Cape yet.
Roger.
Continuing with report, no sequence panel lights showing. Only abnormal position landing bag is off. The EPI is indicating OK. Control fuel is 80 auto, 100 manual. Only really unusual thing so far beside ASCS trouble were the little particles, luminous particles around the capsule, just thousands of them, right at sunrise over the Pacific. Over.
Roger, 7. We have all that. Looks like you're in good shape. Remain on fly-by-wire for the moment.
Roger, Friendship 7.
This is Friendship 7. Have Cape Verde Islands in sight off to my left. Over. Roger, understand. This is Friendship 7. I have no problem at all controlling on the horizon. Over. Roger, understand. You have no problem at all controlling the horizon. That's affirmative.
This is Mercury Control. The Friendship 7 spacecraft made contact with our tracking station at Mouchet, Australia at 10 after the hour. That's 12:10 Eastern Standard Time. Astronaut John Glenn is now in voice contact with Gordon Cooper at Mouchet, Australia. This is Mercury Control.
If you can imagine for a moment firing a bullet, the bullet will leave the barrel of a rifle and follow out the course that the power has given it. In other words, it'll fly on a straight line, and then gradually gravity will pull it down. That bullet, if you could control it, could be raised or lowered. In other words, as it moved forward, you could point the nose up or you could point the nose down. Or you could point it to the left or to the right without changing the trajectory. If you were really clever, you could turn it all around, and still the trajectory would remain the same. Well, John Glenn has been pointing the nose up, down, left, and right. He is flying his bullet. He was supposed to turn it around. We haven't had confirmation that he has. I've got a hunch they may scrub that test, because that test uses a lot of power takes a lot of power out of his manual control system, and he's going to need that power coming up on the second or third orbit when they decide to fire these retro rockets and bring him down safely. This controls problem that John Glenn is having in space is multiplying. It is not improving. This was expected, however, on the dark and colder side of the Earth. the heat of the sun, and he's now between Hawaii and the west coast of the United States on the clock. That's roughly where he should be. The heat of the sun may improve his control. But in any case, they're going to have to decide pretty soon whether to end this flight right now in second orbit or let him try for 3. As you heard him say, he's having more difficulty controlling, bringing back from yaw, bringing the spacecraft back into its proper position and holding it there. He is too busy controlling to carry out some of the exercises and some of the easier problems that were given him to do in space. Therefore, this control system, well, there's another problem with it. It is using up fuel. And they've got to time that fuel to find out whether there's enough fuel there to even risk a third orbit.
We might explain this slightly. This is still controlling the spacecraft automatically, but Glenn, on the fly-by-wire system, is doing this by the use of electrical switches on his right-hand control system. But when he switched over to the manual control system, then this overrode any electronic control of the spacecraft at all, and now he is flying actually by controlling with a hand control and direct cable to the attitude control jets. And these attitude control jets are what keeps the spacecraft in the proper position. After the pre-retro rocket check, the spacecraft will be ready for re-entry if the decision should come from the spacecraft control center. The signal would be transmitted from the Guaymas, Mexico tracking station to halt the flight after 2 orbits, and the Friendship 7 would then re-enter the Earth's atmosphere and drop by parachute in the Atlantic about 450 miles south of the island of Bermuda.